Hey, this is Tracy from APDIG, Automotive Product Engineering and Design Group. What we're going to do today is we're going to give an explanation of a system that we developed and patented. We have utility patent. We've got this wrapped up quite well as far as protection, even though we've got counterfeiters out there already that are copying different aspects. We'll be dealing with that. So what we're doing is we're looking to have a solution to today's motor vehicles. In the past, we were all very accustomed to getting in a vehicle other than putting gasoline in it. We didn't have to worry about it for 100,000 miles. Message pops up on the dash, prompts us to go to the dealer. You go to the dealer, get it fixed, and overall your engine was a pretty trouble-free and very durable piece of engineering. Well, starting about 12, 14 years ago, the automotive industry was forced to adopt technology that would allow even better fuel economy, lower emissions, and more horsepower out of smaller cubic inch, smaller displacement engines. And we all had to adopt what's known as gasoline direct injection. No longer does the fuel come in from a fuel injector and is introduced into the engine through an exhaust port, which would keep the exhaust valves cool and clean. A minimal amount of damaging combustion byproducts were entering the crankcase, and we could get 100 to 150,000 miles out of an engine with minimal maintenance and care. That's no longer the case. These new engines have a technology where the fuel is introduced directly into the crankcase. The fuel is into the combustion chamber, not the crankcase, and it has to be a very extreme high pressure to be able to overcome the compression and the forces that are at play. So it can be anywhere from 1,000 to over 3,000 psi. So this atomizes that fuel much more finely than in the past, allows it to burn more completely. Sounds like a wonderful thing. Better fuel economy, more power. We can actually run higher compression ratio as there's no fuel present during the compression stroke. We're going from a 9.5 to 1 compression to 11.5 to 1 is industry standard right now. And you can run 87 octane. You won't get the efficiency out of the motor, and you won't get the fuel economy or power, but you can safely run that cheaper fuel. And to a lot of people, that is appealing. The problems are several-fold here with these engines. The valves, as they are not getting sprayed and bathed with fuel to keep them cool and clean, build up coking deposits on them. And as you can see in this picture right here, that's pretty severe. Now this is from an Audi S5, a high-end car. This has lost about 30-35 horsepower just from the obstruction of the airflow in. Again, no fuel is touching the valves. Nothing's to keep them clean and cool. So this bakes into a rapidly building deposit that has a negative effect on every aspect of the engine. Now another thing is, because the temperature is so high, this is not a soft carbon that we're accustomed to in the past. This bakes into a very hard crystalline form that is as abrasive as sand. And as some of those particles are shed, Although most will go harmlessly out the exhaust, some gets pushed between the piston and the cylinder wall, and this causes excessive wear and damage prematurely to your engine. In fact, as little as 15,000-20,000 miles, you can start to see damage. Another aspect is, because this is shedding this hard abrasive material, it's getting into the crankcase itself and mixing with the engine oil. So our engine oil is facing just an immense amount of bombardment of not only abrasive particulate matter, but fuel. As I said, this fuel is introduced at 1,000 to 3,000 psi, so 8 to 12 times the amount of raw fuel is pushed past our piston rings. Now, what happens when that fuel is pushed past the piston rings? Number one, it's washing the protective oil film off the rings. So you're going to have excessive wear, premature wear to your rings. But more importantly, or I would say more negatively, is that raw fuel is diluting your motor oil. And that brings us to most of these new engines are specified to run a very thin motor oil. A 5W20 is very common. That motor oil barely has enough viscosity to protect the engine without that fuel coming in and diluting it. When you add that fuel in there, that oil is getting diluted down in some cases to a 0W5 viscosity or even thinner. And this allows premature wear as well because it cannot maintain that protective lubrication film. So we've got several problems that need to be addressed, and of course the automakers have been doing several things to try to alleviate this. One of them would be adding in small port fuel injectors. That has a minimal positive impact on reducing the coking. It does do some, but that increases the rate of detonation and knock retard. So there's some trade-offs there. Others are separating out that oil as much internally, which seems like a good thing, so it isn't part of the intake air charge, but that oil vapor contains all of these contaminants that enter as blow-by: water, raw fuel, acids, abrasive particulate matter are all the main substances that are doing everything they can to prematurely wear an engine and cause damage and problems. So we've got an engine here that is nowhere near as durable as the engines that replaced our port fuel injection engines, but the technology and the construction and design is just amazing in these. So they could even go further and last longer if these issues are addressed. The industry has probably gone as far as they're going to go, other than small changes, because the average new car buyer never keeps the vehicle more than 3 years on average and 40,000, 50,000 miles. So they've lowered the engine warranties from 100,000 mile industry average to 60, 50, even 36,000 miles on many of these vehicles today. The consumer doesn't seem to notice that or question why. So what we've done is we have come up with a system, again, that we covered early, and we are taking and converting, retaining a closed emissions compliant system, and we're pursuing CARB certification in California, which is the most stringent out there. So once we have that, we'll have a completely legal, 50-state legal system that the average do-it-yourselfer can install on their vehicle that will separate out 95% plus of that oil, raw fuel, water, acids, and the other substances that are attacking your engine and overloading your oil's ability to protect. What we're also doing is we're converting the crankcase, as we've done for decades in race applications, to a full-time evacuation. The way a PCV system works is it's using intake manifold vacuum, and I should add here, we have a brand new, came right from the customer picking it up at the dealer, going home and bringing it here, C8 Corvette, the 2020 Corvette. So in developing this system, which converts from part-time to full-time evacuation, removes these contaminants as soon as they enter, doesn't give the majority of them a chance to settle and contaminate the oil. We're removing them while they're still in a gaseous state. And we found some interesting benefits to this. And here is where this becomes pretty revolutionary. Now, this has been, I think we're going on over 10 years of extensive testing, to include 2 years of one of the most respected lubrication labs in the world that did extensive testing on a fleet of GDI-powered vehicles. And we found that we are preventing up to 85% of the intake valve coating deposits, which should bring the average vehicle owner through the life of the vehicle without having to perform a manual intake valve cleaning. We don't recommend you ever do a solvent-based cleaning on a GDI engine, just because you're breaking loose that hard, crystalline, abrasive material inside your engine, and which is comparable to dropping in a handful of sand down into your engine. That is never going to be good. So we are reducing the knock retard because we're pulling out the oil vapors and separating them, so only a scrubbed clean vapor becomes part of the intake air charge. And without intending to, we found that gives us on average an 8 to 10% increase in fuel economy. Again, we had no intent for this, but that is revolutionary. If we could go across the board in the US and get an 8% fuel economy increase, the saving would be in the hundreds of millions, billions of dollars over time. We're looking at the light fleets, like your Grangers and Fastenals and plumbing companies, air conditioning companies, electricians that are out there on the road, and we put these in the light pickups, gasoline engine only. We do not have the diesel version perfected yet. We will install these on these trucks and vans, and not only are we saving that fleet 8 to 10% on their fuel costs, but since we're flushing and removing the contaminants that cause your oil to get dirty and need to be changed, you can now go 2 to 3 times as long between oil changes. So that brings us here, and if you can get a shot of this, this is a car, GDI engine, at 13,396 miles on the same oil. And if you can zoom in to see the comments from the lab technician, this oil is still in as good or better shape than 5,000 to 6,000 miles without our system. The next sample and analysis was done at 20,000 miles and a very similar report. So we've also stumbled onto a huge savings as far as oil change intervals for these fleets. We wanted to give an example of an install. This is a Ford Fusion, and it's I believe it is a 2015. This is the mileage on traveling a 3-hour, 2.5-hour drive here in southern Florida. We only have flat ground, so there are no hills to go up and down. This was reset once the owner got out on the highway, and he averaged 23.6 miles per gallon without our system. We installed the system on his return trip, exact same route, exact same miles, and we had him reset again, cruise control on the highway. He got roughly 9.5, 10% increase in his fuel economy. Well, yeah, to go 10% almost right on the dot on his trip back. Now, as there's residual oil vapors inside the intake manifold, this eventually climbed up about another mile per gallon, so it exceeded the 10%, which is not unusual. What we have got is a system that could save hundreds of millions, billions of dollars on today's light vehicles, gasoline powered, whether they're everyday passenger vehicles, which realistically you're not going to get a lot of people that are going to want to do this, or the light fleet vehicles, which is a natural market for this. Fleet managers and owners are looking constantly for ways to save money. They're tracking every penny that it is costing them to maintain and run that fleet. This is just a no-brainer. The other is performance, like we're seeing here with this brand new Corvette. They want to protect the engines, so majority of the market currently is with these performance street legal cars, and we're protecting these new engines. We're increasing the performance, increasing the economy, extending the life. There's no negative to this, all while retaining a closed emissions compliance system. And I thank you for your time.